We are now looking at section 4.2 of chapter 4, homogeneous linear equations, the general solution. So we will be solving homogeneous second order linear differential equation, and then we will see how to write the general solution. Now when we did the first order linear differential equation, we usually got only one answer. So we wrote our solution. Now here we will be getting sometimes two answers often, because it will be a second order differential equation. So let's see how we begin. Now recall from chapter 1 that a second order linear differential equation can be written like this. So these are the coefficients of the dependent variable y, whose solution we are seeking, the derivatives of y, first derivative and second derivative, and these pt, qt, rt and gt. These are functions of the independent variable t. Now from here, if we want to replace these p, q and r by constants, so this equation becomes a linear second order differential equation with constant coefficients. So we say this is the second order differential equation, linear second order differential equation with constant coefficients. And if we replace the right hand side by 0, like we did in this equation and this equation, so then the equation becomes homogeneous. So at this moment we will be looking at equations of this type. So if you recall again, in last worksheet I gave you a problem from section 1.2 where you had to find the values of m such that e to the mt is a solution of something like this, the homogeneous second order differential equation. So we do the same thing here, but in place of e to the mt, now we are going to plug in e to the rt. So we have to plug it in this equation number 3, but before I do that I need to find the y prime, which will be r e to the rt, and the y double prime, which will be r square e to the rt. So now we plug in here. I have plugged it in for ar square e to the rt. So a is just coefficient, r square er to the t goes for y double prime, plus b times r e to the rt, which is y prime, and plus c into e to the rt, which is the y. Now we can factor out e to the rt and we end up getting a polynomial like this, and this is called the auxiliary equation or the characteristic equation. Now you have to solve this. Basically that's what you will do in this section. You will solve this quadratic. So when you solve, you know that we have the chances are three. There are three chances. One is that you get two distinct real solutions or roots, and then second is that you get one real repeated root, or you can get two complex roots. So in this section we will talk about the first two categories, the distinct real root, two distinct real roots, or the other one will be the repeated root. And then in section 4.3 we will discuss the ones with the complex roots. Okay, and so the general solution will be written as a linear combination of the two roots that we have. So when we have distinct real roots, so let us say we have r1 and r2 are the roots, then we say, okay, y is equal to e to the r1 t is the root, and y is equal to e to the r2 t is the root. But then we want to write our general solution, and the general solution is given as the linear combination of the two roots. So the general solution will be written then like this. Okay, C1, and now C1 and C2, these are constants to be determined by what? By the initial condition. So if we have to solve an initial value problem, we will be able to figure out what C1 and C2 are. Otherwise they just stay in the solution. Now if you have repeated roots, so it means your roots are e to the rt and e to the rt. So it doesn't make sense to make a linear combination of these two, because you can just add them same terms. So you just get a number times e to the rt, but you should have two two separate things in order to make the linear combination. So what we do, we take one root as e to the rt, but the other we take it t times e to the rt. Okay, so that our general solution will look like this: c1 e to the rt plus c2 t e to the rt. So do not forget to include the t there. Okay, let's look at some examples here. First one, find the general solution of differential equation y double prime minus y prime minus 11y is equal to 0. Now when you have when you will see or solve these type of problems, you don't have to start with e to the rt. You should be able to directly write it. Actually I'll show you from here that if you notice, when our equation was ar square plus br plus c is equal to 0. So this is equation number 5, and we got it from where? We got it from by plugging the e to the rt in the equation number 3. So if you notice here, this is a y double prime, and here you are getting ar square in the equation 5. And then we have by double prime, and you are getting br. Then we have cy, you are getting c. So if you can, look at them together, so what is happening? So you can directly write your auxiliary equation. You don't have to do all this work in every problem. So that's where we will start. Characteristic equation or auxiliary equation will be, so in our example, we say auxiliary equation will be r square minus r minus 11 is equal to 0. Now this I don't think we can factor it, so let's use the quadratic formula for that. So that gives me r is equal to negative of negative 1 plus minus square root 1 minus 4 times 1 times negative 11. So whole thing divided by 2 times 1. So which gives me 1 plus minus square root of 1 plus 44. So be careful here. Often students forget this negative sign to put in, and then they end up getting a complex numbers, which will be not the correct answer here. Simplify it a little bit. So notice that it is 1 plus minus 45 square root over 2, but 45 square root can be written as 9 times 5. So this is a perfect square there, and I think this is the highest perfect square we can get there. So I can pull that 9 out of the square root, so I get 1 plus minus 3 into square root of 5 over 2. So these are both real numbers. Okay, so our r1 you can say is 1 minus 3 into square root of 5 over 2. This whole thing is our r1, and r2 will be 1 plus 3 into square root of 5 over 2. Now you may not always get numbers like this. You might get like r1 is 3, r2 is negative 1, things like that, which is okay. But in this case we are getting that. So how will I write my general solution? So the general solution will be general solution y is equal to c1 e to the this whole thing r1t. So 1 minus 3 square root of 5 whole divided by 2 times t plus c2 e to the 1 plus 3 square root of 5 over 2 t. So that is your general solution. Okay, looking at the next example, so we have y double prime plus y prime is equal to 0. So what is our auxiliary equation? So auxiliary equation is r square plus r equal to 0. Notice here this time it's an IVP. Okay, so which means I can factor. So r times r plus 1 is equal to 0, which gives me r is equal to 0 or r is equal to negative 1. So that general solution y is equal to c1 e to the 0t plus c2 e to the negative 1t. So I can say negative t, which is equal to, now e to the 0 t is e to the 0, which means 1. So I get c1 plus c2 e to the negative t. So this is my general solution. Now to solve for the, okay, maybe I should write it discretely or explicit. Well, this is explicit, but I want to write it like clearly in terms of y. So y equals c1 plus c2 e to the minus t. Now we will apply the initial conditions, but notice here one initial condition is on y, which I can do right now, but then one is on y prime. So I would like to do the derivative here as well. So y prime will be equal to 0 plus c2 e to the minus t times negative 1, the derivative of negative t, which is negative 1. So we end up getting is y prime is equal to negative c2 e to the minus t. Okay, now we use the initial condition. Y of 0 is equal to 2. This gives me 2 is equal to c1 plus c2 e to the 0. So it is basically just c1 plus c2 is equal to 2. This is an equation we get here. Now for the second one, y prime of 0 is equal to 1. So this gives me 1 is equal to negative c2. Basically that's what it, because e to the 0. So 1 is equal to negative c2. That's what we have, which gives me c2 is equal to negative 1. Now we bring that c2 over here. So c1 plus negative 1 is equal to 2. So you can see c1 is equal to 3. So once you have the c1 and c2, now you should put them back in the general solution. So therefore, final answer you can say, or general solution, is going to be y is equal to, actually this is a particular solution, my bad, sorry. Because now we know exactly which curve is. So final solution you can say, or just solution, y is equal to, c1 is 3. So I will say 3 plus minus, actually because c2 is negative, 3 minus e to the minus t. So that's how you can find the particular solution. Okay, let's look at one more example here. This is also an IVP, but this time our characteristic equation is, or the auxiliary equation, r square minus 4r plus 4 equal to 0. But what is that? That is actually a perfect square. That is r minus 2 whole square, which means r minus 2 is equal to 0, which implies r is equal to 2. So what is happening here? We are getting a repeated root. So r1 is 2 and r2 is 2. So in this case, our general solution will be y is equal to c1 e to the 2t plus c2t e to the 2t. I will do the derivative here because I have to use the initial condition, and one of the initial condition is on the derivative. So we get 2 c1 e to the 2t plus c2 into, now over here we have to apply the product rule. Notice that this is product of two functions, so we have to apply product rules. That's why I'm going to keep the C2 out, because it's a constant. So we get t times derivative of the second, which is 2e to the 2t, plus keep the second function as it is and multiply by the derivative of the first, which is 1, and then just clean it to 2c1 e to the 2t plus c2 2c2 t e to the 2t plus c2 e to the 2t. Okay, now we plug in the initial conditions. Okay, over here let me do it. So y of 1 is equal to 1. What does that mean? This gives us, we will plug it in here. So y of 1 is equal to 1 means, this implies 1 is equal to c1 e to the 2. Now this time t is not 0, so plus c2 e to the 2, because t is 1, so, and the other one, y prime of 1 is equal to 1, implies 1 is equal to 2 c1 e to the 2 plus 2 c2 e to the 2 plus c2 e to the 2. So this combines and gives me 3. So I'm getting, so I have one equation is, let's write it that way. So first equation is c1 plus c2. I can factor out the e2 here. I don't need to, well, yeah, let's factor it out. So is equal to 1. That is one equation. And the second equation is c2c1 plus 3c2. And then we have e to the 2. And this is also equal to 1. So basically, I can move the e to the 2 on the other side. So I get c1 plus c2 is equal to e to the negative 2. This is equation 1. Let's call it 1 prime, because I'm getting it from the 1, but it's a little bit changed. And this one is 2c1 plus 3c2 equals e to the negative 2. So now we can just take we can solve by elimination. So what I do, I multiply the first prime equation, so this equation, by negative 2. So I get negative 2c1 minus 2c2 is equal to negative 2 e to the minus 2. And now I will add it into the second equation. So I will add these two. So I get 0. Here I just get c2. And here I will get negative e to the negative 2. So c2 is equal to this. Now I can just plug in c2 in some wherever in equation 1 or 2 and solve for c1. So I use, let's say, 1 in plug in equation 1 the value of c2. So I will get c1 minus e to the minus 2 times e to the 2 equals to 1. So distribute, so get c1 e to the 2 minus 1, because this, when you multiply these two, you get e to the 0 is equal to 1. So now we will take this one on the other side. So c1 e to the 2 is equal to 2, which implies c1 is equal to 2 times e to the negative 2. So this is the value of the c1. Therefore, y is equal to 2 e to the negative 2 times e to the 2t minus, because c2 is negative, minus c2. c2 is minus e to the negative 2. So minus e to the negative 2 times t times e to the 2t. Now we can actually combine these, so we get 2 e to the 2t minus 2 minus t times e to the 2t minus 2. So this will be our final solution. Now this might look a little weird, but I think if you do by yourself, just following the guideline, you should be able to get it. Okay, let me stop here and do the rest of it in the second video because it's getting too long.